time out today. Good morning and good afternoon for some, and good evening for others. We're going to be covering Engineered to Fly today in the 3D Experience and offering from Dassault System. And Edward and Fabian, are you there as well?
We just connect.
Okay, great. You guys are live on the line, so just be cognizant of that, and we shall proceed. We've got a packed presentation for you today, a couple of slides, but of course, I think what's most impactful is to actually see this solution in the live format, so I'll be doing a live presentation today. Before we do that, many of you are already Inceptra customers, but for those that may be new or want a refresher on some of our credentials, we've been in the CAD/CAM area for over 25 years. We're spread across North America. We are Dassault's largest partner in North America with over 1,250 customers. We're certified in both training and the solutions that we provide, and that includes the 3D Experience and the V6 portfolio. So to set the premise and a little bit of the background of where the 3D Experience has come from in the past, you know, we've had very separate brands that have been very isolated in how they work and interact with each other. And we get often down into the product and the functionality of each one of these brands. Catia, in specific, is very well known for that it's very segmented, and we're very used to all the trigrams that exist within that particular brand. And with the recent acquisitions and advancements of these brands, Dassault has brought them together in what they call the 3D Experience. Specifically, what they've done is that they've merged the technology so that they work together to address the specific needs of the 12 different focus industries that they've selected, and that is on the right-hand side of that screen. Specifically for aerospace and defense, you can see that they have a number of what they call industry solution experiences. So, for example, winning program might be for someone like a Boeing or Northrop or a Lockheed Martin, and how to actually manage and go out and win a particular program, maybe say from the government. So there's all of these industry solution experiences that are out there, but the one that we're going to be focusing on today for the aerospace and defense area is Engineered to Fly. So to set the premise of where we feel this solution fits is really some of the Tier 1 and Tier 2 suppliers, and some of the Tier 3 and Tier 4, and even sometimes a little bit beyond that, depending on the interaction that you have with those tiers. But really, that is our sweet spot that this solution has been developed for. And so why did we go and develop that? And that is to address some of the technical challenges that we're seeing as trends in the industry. Basically more complex parts, and going from, for example, metallic parts to composites, or from systems from just being pipes down to fluidics and electronics involved, or more importantly, even delivering integrated systems. So it's not just piece parts and components anymore, but it's integrated solutions with sensors and reactions and various different components in that capacity. As well as from the business side, there's pressure on these tiers or the suppliers into the supply chain about the pressures in the global business market. And so, you know, there's consolidation, there's mergers and acquisitions that are trending in our industry. There's the attitude of risk sharing from the OEMs, that it's not just satisfactory anymore to simply participate from a transactional relationship, that they actually want you to be a risk-sharing partner, and then being able to survive the ups and downs of the trends with managing the rate and demands on production being able to take advantage of that when the opportunity should arise. So all of that were the impetus for these common core functions of why this solution was developed, and that is to help the supply chain win more business, do a faster ROI on your technology investments, and drive higher margins. So again, just describing this a little bit more, how do we do that? So one, we're going to work on improving the bidding process. So describing how to standardize on the bidding process, how to react to the bidding process, and that's part of this solution. Also executing on target, so on time and on budget for our projects that we have, as well as the integrated value streams, and that's for the next 3 through 7 here, whether it's composites or machine components or systems and equipment. And then finally the validation of this so that you are traceable and auditable and you have that built-in conformance at the end. So the solution is designed to basically cover those specific areas. So uniquely, what does that offer? So when we talk about items like digital continuity, what we're talking about is all working on the same architecture, having the same access from design to that data, from design through manufacturing, so that we can run the proper simulations and understand the impact results of that. Driven and controlled execution, where we are providing the standardized method for the routes as well as the traceability for your OEMs when we're actually executing on the project, as well as the operational efficiency gains that we're promoting, which is really the reuse of RFP results, various different risks and opportunities that we have with the project, and a templatized approach where we're not reinventing the wheel each time we go through this process. We're using the standardized templates to help accelerate our overall efficiency. So with that, I will present a demo synopsis or scenario here that's really in 4 different stages, and we'll try to break that up just a little bit so that it's not just one continuous flow. You understand, these various different areas and impacts that we have throughout the presentation. But we're going to be going through the bidding process, the implement of integrated governance, the optimize of the manufacturing process through digital continuity, as well as the implement integrated support for audit and quality. So with those 4 different areas, I'll try to segment up the presentation and demonstration so that we can kind of understand a little bit better what each one of those will be providing. Jason, did you want to throw up our first poll?
Yeah, thanks, Bill. I think that makes good sense. We'll probably have a question for the audience here that we'll keep up for about 20 seconds or so. Just collect a few answers, give you guys some time to respond or reply to how many RFPs are submitted by a supplier in a year.
So while we're going through the poll and that poll is open, really what we're talking about when we talk about improving the bidding process is that we're going to be sharing the documents, whether it be from the sales or the technical department. We're going to be using templates with standard deliverables that will be required, and then the reuse of the existing project and components. So we're trying to keep this a little bit interactive. Did you share the poll results, Jason?
I did, yes.
Yep.
So thank you to everyone who responded.
Yeah, that's great. So I've got a lot of responses on that, and the number 3 answer of 150 is the proper answer. So when responding, what that is there are a lot of requirements to respond to RFPs that are out there, 150 per year. Even if you're not at that level, that is a tremendous amount of work that needs to be tracked and utilized and attended to. So let's take a look at Engineered to Fly. on the 3D experience and how we can actually work with some of the RFPs. So I'm going to maximize my window here. I have logged in through a web browser, and I have access to my dashboard. So right now, I'll be playing a couple different roles. The first role that I come in as is a project manager. So you'll see up at the top, I've got my RFPs. These are the various different programs listed that I'm participating in. And because I'm a project manager, I also have a collection area for my RFPs that are gathered together in one dashboard view. So off to the right are my key performance indicators, my KPIs, and I can see out of the pending tasks how many are outstanding, what kind of timeline I have on these various different projects. By mousing over them, I can see what the various states are. Green means that I'm obviously within my time frame that has been set out. Reds are areas of attention for me to continue to investigate. I've got pending deliverables, pending issues, as well as the amount of effort that has been planned and how much has been completed up to this point. So I get an overall snapshot in one specific area to look at all of my RFPs all in one particular dashboard. If I want to dive down deeper into that, I can certainly do so. Let's check out the one with the red dot, which gives us a reason to investigate a little bit further. As I dive down into that particular program and RFP that I am responsible for responding to, I can look at my burn down chart, how many tasks have been completed, on what date, what was remaining, and I gather that information that way in a visual sense. I also have the tasks and deliverables, as well as a Gantt chart for what the process has actually lent us to. You notice that I do have an issue, and that one of these issues is actually outstanding and it's overdue. So let's take a look at that. Again, diving down deeper into some information. Specifically, what I'm looking for here is, how do I respond to this? Who is the owner of this? Who's responsible, and what exactly are they supposed to be doing? So we've got the owner identified on this particular issue, and I can follow up with that user to find out exactly where they are and why they haven't created or responded to that particular task that they're assigned with. As well, besides the RFPs that I have, I also have the various different projects which we're participating in. So if I take a look at a couple here, we're going to dive down deeper into this later in the presentation, but I'm going to take a look at just an engine attachment project. So much like the supply chain or our customers in our supply chain, we do work on multiple programs, and we do work on multiple projects for those programs. So we need a methodology and a way to organize the various different programs and projects that we're actually working on. So when I dive deeper into that particular project about the engine attachment, you'll see that I get the information and kind of a dashboard view again about that particular project. And this is based off of really the Advanced Product Quality Planning Initiative, or APQP, that we have really seen resonate in the automotive industry, but is also getting a lot of attention in the aerospace industry. So when I create a new project, I don't have to create this from scratch. We're creating it from a template which has standardized phase gates through here. And not to spend too much time on this, as I said, we'll be diving into this a little bit later. But as the phase gate goes through, you'll notice that the first couple ones are all on proposals and responding to the customer or RFPs. And then we actually get into the execution portion out of this. The legend is letting us know that the first 4 stages were actually proposal stages, and then we got the project awarded to us. So if I scroll to the right, you'll actually see that we are in production on this particular item. And I am we're in production, and we have had that project awarded to us. So let's dig and investigate a little bit about the content that's really here under this particular project. I go into the folders. A folder acts just like what you would expect a folder to act like. It's a canister or a container for the information that maybe has been provided by our customer, or information that we want to add into the various different folders. So I'm looking under the folder that is the RFP requirements, and you'll notice that I have a written specification here. Go ahead and take a look at what that written specification is. And it talks about the engine attachment, the part that we're responsible for, the design, a couple different views on here, the tasks that are associated to it, the different options for manufacturing that we have. So this is part of the RFP. They want to change the mounting design on this particular part, and we're going to go ahead and investigate that. So potentially we got you know, something that we're needing to respond to, an RFP, and I could email that out, and we could send it throughout the organization and have it get lost, or maybe not attended to, or maybe not tracked. But what we're going to do is show the 3D experience and engineered to fly approach to how we respond to an RFP. So as a program manager, I've made this available in this folder, and the manufacturing engineer has been notified through the workflow that they need to participate on that particular RFP. So I'm going to switch hats and switch roles, and I'm going to go from a project manager now to a manufacturing engineer. So that exact same view that I just had in the web browser with the 3D experience is now mimicked here on the thick client for the manufacturing engineer. And in fact, it's exactly the same information. I've got the project information, I've got the folders, I've got each stage gate and review information per that stage gate. So I am able to see visually in 3D what was there in the web as a 2D information. So I'm participating in that project and RFP plan directly here. We'll take a look at the requirements again. It's exactly the same document, one that we just reviewed from the web. So the same kind of look and feel is present both in the thick client as well as the thin client. The compass is up here. The compass is up here. So we're trying to get the synergy going between these two environments or interfaces. So as I've looked at that document, I understand what I'm tasked with. I'm going to review the information that's here and take a look at the actual part that is in reference. And this, even though we interact with multiple CAD systems, I'm going to be working in Catia on the 3D experience. So this is the 3D experience and CAD or Catia at this point. So the same functionality, if you're used to this in V5, still exists. The displays of captures, which snaps us to a specific projected view and orientation, as well as displaying the various different tolerances that are there. This is very prevalent now in the aerospace industry to provide model-based definition where all the specs, the materials, the handling, the call-out is all identified directly on that particular part. I'll also go explore just the geometry now of that part without the annotations. And what I'm really going to be looking for is anything that is similar to this part. So I'm the manufacturing engineer. The premise is going that I need to find out everything I can about this part. I'm looking at the information that has been provided, as well as I'm going to perform a similar search. So I'm going to reuse any entries or items that I find that are valid inside my database to find out past projects, to find out components that may be relevant to what it is that I'm trying to accomplish. So at any time I can go take a look at the properties of that particular item, find out you know, the description or any kind of project that it was on, or if I want to, I can explore this with its parents, so I can find out what projects, what RFPs has it participated in the past, what machining operations were used on this particular part. So as I go through, I'm trying to reuse the information within my database itself so that I can gain that efficiency when I'm responding to this RFP. So we'll take a look at the actual machining of the part as it stands now and investigate this a little bit further. So here's our part that is in the machining center, and it's our responsibility to find out everything that we can about this. And we take a look at that this part itself is actually an older revision. So we've got a revision A in there. With the Business Essentials overlay, I can find out very easily which part it is that is out of date. The same items of the capability that you're used to inside of Catia, where we can look at properties and center the graph, etc., exist inside of here. And I'm investigating this part to really find out what versions are available on this part. There could be multiple versions on here. In this case, there's a version A and a version B. Let's go explore. Actually, let's just open this up and take a look at version B and try to determine exactly what's different between these two. So I'm in investigation mode, manufacturing engineer, trying to figure out the differences between version 1 and version 2, or in this case version A and version B. I'm going to do a design review on this, and it's much like an assembly. We bring that part into the actual review, and then we can do various different tasks on it. And one of those tasks is really to compare it to anything, but the prior version would be nice to know. So we take version A and version B, overlay them in this review session, and very quickly determine what is different between one version and the next. So you can see that the old pattern is a 4x4 pattern, and the new pattern is a 5x4 pattern as far as the holes or the mounting items are concerned here in the back. Everything else, we get a little bit of a bleed through, especially with the go-to meeting, but everything else in blue is common with those. So let's take a look at that manufacturing operation again, and notice that the older part, the 4x4, is still in here. I'll bring up our assembly tree. And we're going to go ahead and simply replace this with the latest revision. So as the manufacturing engineer, what I'm trying to determine is this still going to be valid when I replace this part? Is this feasible? Can we do this? Do we have the capability? And so that's really what the intent is for me to investigate this. And to go to the fullest extent out of that, I'm going to go into our manufacturing operation and make sure that we can actually manufacture with the new requirement. So because the whole change, we're going to go into the drilling routine. Of course, I would have to update everything that has changed about the part. So I'm going to go add the hole pattern for the new center points. And then we'll validate that that tool path actually works. This is part of that digital continuity. This is part of being able to always work on the same data set, being able to validate being able to verify exactly what is happening with that data. So quick little change. We like that progression. The other item that you'll notice is that we have changed the part, and so what we're also want to validate is the fact that on our manufacturing program that all of the tool paths are actually going to be able to be updated properly so that I can submit that information. Okay. So at this point, we've replaced a revision of a part. I've investigated exactly what needs to happen. I can now respond to the RFP in whatever format that is required within the workflow, whether I'm submitting a work instruction or replying to a workflow and approving it, whatever that might be. We're going to investigate that a little bit later in the presentation. So at this point, we've kind of gone through stage one. Let's go back to our PowerPoint. And so that was a little bit on the bidding process, the control, and being able to share information all the way from sales to the technical departments. When we talk about the governance associated with this in the next step of the presentation, we're talking about really getting an understanding of the data, the bid process, being able to manage resources from a single location, the approval process, the deliverables that are required, and then the ability to communicate the appropriate documents on a regular basis to the authority or to the OEM. So let's take a look at how we might do that. So I'm going to head to our home page, and as we mentioned, we have multiple programs that we're working on, whether it be the A380, the 737, or the 787. And this time we'll talk about the key performance indicators with regard to a specific program, pending task timelines, pending deliverables. If I want to know, what the pending tasks are for the jack that we have that we're working on, I can immediately get that. If I just want to see across all of the projects how many tasks are actually overdue, no matter what project they're from, but all from the same program, I get a snapshot of that. If I go to the pending deliverables, it'll let me know which documents are still waiting, which ones are pending, and which ones I need activity on. So a fairly quick and easy way to navigate through the various different projects that are associated to a specific program. But when we talk about governance, what we're really looking for is how we manage the statement of work that's associated to a particular program. So we're going to investigate this program a little bit further and take a look at the information that we can get out of here and how we manage that. So as we mentioned, the top here, the different tabs that give us access to the information that is associated to this particular program, one of the driving factors, of course, with any program are the contracts that you receive, which really dictate your statement of work. So as I take a look at a particular contract, again, we're focusing on the engine attachment. When we look at that particular contract, this contract is your statement of work. This is exactly what, why, when, how, the products, the delivery, the packaging, the inspection process, basically the requirements of the statement of work that you are responsible for. So as I dive down into taking that contract and taking a section out of that contract, what we get out of that contract are basically items like our contract line item numbers and the responsibility, so that I can break down the contract into specific requirements that I am responsible for, as well as the work breakdown structure elements, so that I can assign tasks to these specific requirements that are coming from the various different sections that are actually coming from the contract itself. So we're managing from the contract on down, making sure that we have associativity that way, as well as when I dive into the program itself, we'll take a look at the additional information that's actually here. So this is the dashboard that we had a little bit earlier. It showed that we are executing on this on a production level. And we can take a look at the Gantt chart that's associated to that. So these are the various tasks that we have. And again, this came from a templatized version of the APQP. So if you have something that is different, we can certainly import that and use it. But this is the Gantt chart of all the tasks that are responsible to go through that particular session or that particular information associated to each one of those phase gates so that we know we are addressing them appropriately. Let me move my docking over here to the other side, getting in my way. As well as, let's take a look at some of the other information that's here. We've got users that we have that are collaborating on this particular project. We've got various different tasks that are assigned to users. Here, our user Echo Fox has certain responsibilities. We can dive down into the tasks that are assigned to that particular user, whether they are behind or ahead of schedule, how many tasks and accuracy, how much task accuracy they have in addressing the task items that they are responsible for. We'll bring the that control panel for the users down. We can also see what kind of, or manage more specifically, the access of the permissions. So on this particular project, we have multiple folders that are here, and we've got various different participants that are participating in this project. So they may be outside customers, they may be vendors, they may be suppliers to us, they may be employees. So we can give inherited rights, so that means that whatever the default was that was set up on the particular folder, that's the rights that are going to be broadcast out to the users. Or we can set specific rights to them as far as their access to this. So whether or not they have read write, add remove, or none. Maybe that particular user is outside of our company and we don't want them knowing about a particular task or project or RFP that we're responding to. So we can control the access permissions in here. We've talked about the stage gate process and how that's tracked. And the other one to broadcast here is our risk management. So we have a risk queue, which is really managing the various different risks that are associated with a particular project. Often these risks are broadcast up to the C-level of an organization so that you can manage them. So what are the status of the risks? What is the mitigation process that you're going to put in place to mitigate that particular risk? What is the likelihood and the consequence of that risk? And when we start to track and manage those particular items, what that does is it gives us the ability to share that from project to project and gain from that experience. Not only is there risk management, but there's also opportunity management within here. So what are the potentials for our opportunities? What maybe it's a new process that we can start to employ, and what would the benefit of that particular process enable? So again, what this is allowing you to do when you start talking about risks and opportunity management within here is that it's going to increase your bid-win ratio as well as make you more profitable on the bids that you do win. So that's a little bit of the snapshot of the governance that's also associated to a particular project. So we'll continue on with our presentation and take a look at the third stage here. Jason, I believe we have another poll.
That is correct. So I'm going to launch another question here that will be open for just about 30 seconds as well. How many civil aircraft are produced in a year worldwide? Interested in the responses on this one.
So if you could participate in the poll, that's helpful. Also kind of sets up the next topic, which is, optimizing the manufacturing process.
Sure. So we'll give it another couple of seconds here, and then I'll go ahead and close out this poll, and we'll share the results.
All right. And we'll give everybody just a little bit, but in this portion of the demonstration, we're really going to be talking about, the simulation, the impacted resources that we may want to simulate, managing the risk by that impact simulation that we're going to conduct, and then optimize the manufacturing process and costs accordingly. So talking about really interacting with the execution portion of this environment.
All right, so Bill, the results are in, and we're showing those now.
Excellent. Again, when in doubt, pick answer number 3, and that is correct. It is 1,700 currently. What is expected is that rate is dramatically going to increase over the next number of years. So again, business as usual and status quo, and the way that we're currently conducting business may not be the proper way to move forward. So let's take a look at engineered to fly and how we can address some of these rate type issues. So I'm still in the engine attachment directory, project, and what I'm looking at is the folder where we have project evolutions. And so we're going to look at a requirement spec and a proposal from our customer that basically is proposing a change to what we are executing on in production right now. And so when I look at this, the requirement set, all of the requirements for this particular project are broadcast, mass, tensile strength, crack resistance, but there's also one that's specified in here that's called delivery rate. The one thing that I do notice about this is that there is an active engineering change that exists on the delivery rate. So this is in a specific area, in the evolution area of this project, and I'm going to investigate a little bit more as to what that engineering action is, or what that engineering change action actually is. So as I bring up the delivery rate and the change, you'll notice that yes, there is an active engineering change on here. Let's go take a look at what that engineering change proposed or proposal actually is. So the customer is requesting something from us. We are in production on it, and any change that we have has to be tracked and traceable and, of course, auditable. So it looks like they are requesting that our delivery rate go from 40 pieces a month to 60 pieces a month. So I now have this information that I need to digest and, more importantly, actually need to account for within the project itself. So at this point, I'm going to go and schedule this. We've seen the Gantt chart of all of these tasks as we've gone through our phase gates. Let's just look at the last one with the feedback and, the corrective actions, and just pull up the specified tasks that are associated to that particular block in our workflow. So as we look at the start of production, the engineering rate requirement change has been broadcast, and we've made a task that is associated to that and assigned to a particular person. So I can, of course, link items to that task that we've created. We'll take a look at this. So we're trying to now schedule this particular rate change requirement or proposal from our customer. Currently, it's under review. It does go through a workflow process on whether or not we can handle this particular delivery rate from 40 to 60 per month. In order to investigate that change further, we've also created another task, which is a delivery rate change, and for that, we've created a manufacturing change action. So when I take a look at the manufacturing change action, what this is that it's a gathering location for us to put the pertinent information about what we need to investigate to see if we can incorporate this actual change, as well as gives us a forum for tracking and having traceability to the value or to the results of that particular investigation. So I've got this manufacturing change action that's here. It has been assigned to the manufacturing engineer. So let's go take a look at the manufacturing engineer's response to that particular change request. So the icons match. We are getting, again, the capability of seeing that we're all working on the same architecture and the same database. I have the manufacturing change action broadcast to me. I can see which affected items are actually here and what specific manufacturing processes it is that I need to account for when they're talking about a rate change on this particular part. So we've got a manufacturing process that's here that I need to investigate. So that information is delivered to me. It's all combined into one manufacturing change action, and I will take and investigate exactly how we are currently doing this. So this is the current process that we use, and it's a little bit simplified for our demonstration here, but we're delivering the raw material. How we actually make this is that we go through a roughing stage to bring it down to size. We do a semi-finish operation, and then finally we're doing a finish operation on that particular part. So though there may be a machine tool that is capable of doing all of those, really what this is multiple subsystems that are delivering this. So take this example and maybe replace it with an assembly example where you have different substations that are putting parts together. Or you have different machine tools doing different operations, which is the case right here for how we're addressing the manufacturing of this particular part. So as I look under each one of these components, they're broken out into their operations that are assigned to each one of these subsystems. So some subsystems have more than one operation associated to them and what they're responsible for in the overall manufacturing process. I can further investigate this by pulling up a Gantt chart of that particular process. So as I take a look at that Gantt chart, what we have are each of the subsystems and their associated operations that exist on that particular subsystem. So what I'm trying to figure out is how do I increase the rate in the overall production capacity that we have. And so as I look at this, I'm looking at how do I basically figure out when the next cycle is actually going to start. So as I duplicate this process, I'm trying to figure out when I can release this next part into the system and figure out the utilization of each one of these subsystems that are there. So as I drag this across, what we're seeing is that the first stage or subsystem is basically under 100% capacity. That's why it's showing up in green, so we can handle that rate. But then we hit the next subsystem, which is over capacity or at 150%. So as I drag that out, we're noticing that now I'm below 100, but when we get to the third subsystem, I'm still not where I need to be able to handle any kind of rate increase at that level. So I continue to simulate what it would be and what time frame I need to put this out at in order to be able to handle a certain release rate of those parts down to the shop floor. So 3 out of the 4 subsystems are able to handle this capacity, and you notice that the third subsystem is basically at this time frame at about 200% capacity. So as the manufacturing engineer, I have a decision to make. If I have another subsystem which is exactly capable of handling these operations, I could put 2 of those machine tools, if that was a machine tool, onto this to handle 100% of the capacity and continue to keep my workflow going at this particular rate. The other item that I could do is to see if I can actually make this particular operation more efficient somehow. So we get various different simulation capabilities with the process planning, as well as the capability to use this digital continuity to investigate further what exactly it is that we are trying to optimize. So here's the part in the manufacturing process, and we're going to see if we can modify anything in here as the manufacturing engineer to make this more of an optimized approach to our particular manufacturing operation. So as I investigate this, I'm looking at various different tool paths and manufacturing approaches to here. One of the options that I do see, or that I see that I have not employed, is basically a high-speed milling approach. This is a good candidate for it for pockets, and I'm going to investigate what it would take to basically introduce high-speed milling to this particular operation. We'll do that for both the transition and the corners. And I will validate that result by doing a simulation of the actual tool path. So of course my work wouldn't be done on just one of the tool paths. I would see if there's any feed rates that I could optimize as we go through. I'm reviewing the tool path, making sure that everything is still corresponding and operating as expected. And then I'm paying attention to the pocketing routines, which I have just now employed a high-speed milling approach to. So for demonstration purposes, again, what I would be doing is investigating all of these, making sure that we could try to increase rate that way. You'll notice that part of my responsibility is also to make sure that any changes are valid changes. So I'll go back to my manufacturing program and update that program. So part of my responsibility to do that, as well as prepare some of the deliverables that I have that are a requirement from the manufacturer. Remember, this is in production, so any changes to this need to be documented. Maybe I actually need to execute and put out the NC code and the app source file to this to let everyone know and manage the new G code that's going down to the machine. So if I would execute this, we would actually broadcast that information out. So very quickly, as I notice I'm running close to the end of the time frame, we're going to take a look at the last step here. And that's really the support for the audit and quality, and that would be the reporting of this information into one location that is manageable, traceable, and can provide the details for the audit. So as the manufacturing engineer, I'm responsible for participation in this delivery rate change. I've just investigated it, and I found that we do have a satisfactory answer in this case, and so I can pull up that manufacturing change action and participate in the workflow. So we're going through this fairly quickly. There would be approvals and sign-offs and requirements, but if I put this to complete and I had the permissions to put this to complete, what this is actually doing is recording the fact that I have investigated it. It is a completed task, and it's allowed to go into the database and record that information. So instantly, once that's done, it is broadcast out to the schedule, and we get an instantaneous result to the overall accounting system for this. I'm going to let that continue and also go to the other portion of this, which is our folders. And under the folders, we have our quality area, which is also providing the details for the audit. And inside that engine attachment delivery rate change, what we have is the ability to basically track and manage the files that are associated with any of these changes, much like we would manage our CAD systems and our CAD files. So, you know, my responsibility would be for whatever workflow or for whatever machining operation that I have, I would upload that file and broadcast that and present that and bring that to put it into the quality document area. So that gives us the complete closed loop of satisfying the criteria of participation in the workflow, the accountability, the traceability, as well as providing the supporting documents for quality. So Jason, I know there's just a couple minutes left. I do want to open this up for questions.
Absolutely. Yeah, and thanks, Bill. Really appreciate you introducing the Engineered to Fly solution on the 3DEXPERIENCE platform. And once again, just thanks to everyone on the call for all of the comments, feedback, and questions so far. Again, I would quickly like to thank Edouard, Robin, and Fabian Roger, who played a major part in the development of the solution that Bill showed us today. So, you know, thank you guys for your support and participation today. And please, by all means, extend an invitation to right now at this time to voice any additional comments, feedback, or pose any questions to the team that we have assembled here. There's a couple ways you can do that. In the GoToWebinar panel, you may use the raise your hand feature if you'd like to speak directly, and I can open up your line each in turn, or again, you may continue to use the questions panel to submit your questions at this time. And at this point, you know, please feel free to stay on with us as long as you can, or to drop off as necessity demands. We'll attempt to address all the questions within the remaining time that we have, and can certainly stay on longer if needed or follow up individually by the time it's more convenient to you. So at this time, we will open it up for questions. There was one question that came through privately that I can probably share or paraphrase. Really the answer, the webinar today was recorded. So if there's any information that you feel that you need to review again, or someone else within your organization that you'd like to share this presentation with, we will be sending out a link to the recording. I'll make that available to you. And please feel free to follow up with this if you desire to do so.
Well, Jason, if there's not any questions coming through, hopefully we've done a good job in explaining and giving an introduction to Engineered to Fly on the 3DEXPERIENCE from Dassault Systems.
Absolutely, yeah. If there's no more questions, then this will conclude our webinar for today. So thank you, everyone. Thank you, Edouard, Fabian, and Bill, and have a great day, everyone.